Welcome to AI Frontiers, Seeing Beyond the Pixels. In this episode, we showcase 72 new papers in computer vision and pattern recognition, exploring how artificial intelligence is learning to truly see. We will delve into generative models, multimodal systems, explainable AI, and take a deep dive into our featured paper of the day by Caldera and colleagues. Join us as we unpack the trends shaping tomorrow's intelligent machines. Every second, over 100,000 images are uploaded online, yet even the most advanced AI models can still confuse a chihuahua with a blueberry muffin. This surprising glitch in machine vision highlights that, while human vision excels at interpreting context, AI continues to struggle in this area. The central question remains, can machines be taught to genuinely understand what they see? Today's research is moving us closer to that goal, with innovations designed to bridge the gap between perception and understanding. Computer vision is the field dedicated to empowering artificial intelligence with the ability to interpret visual information. The mission extends beyond simple detection toward the deeper understanding of scenes, actions, and even emotions. Pattern recognition, a closely related domain, enables AI to spot regularities and predict outcomes, forming the backbone of technologies such as facial recognition, autonomous driving, and advanced medical diagnostics. In this episode, we examine 72 new research papers, each offering fresh insights into these critical technologies. Consider computer vision as akin to a master chef's process. Just as a chef recognizes, understands, and artfully combines ingredients, AI must interpret pixels, detect patterns, and assemble scenes into meaningful knowledge. This technology forms the backbone of modern smartphones, autonomous vehicles, healthcare diagnostics, and social media applications. Pattern recognition empowers AI to classify objects and predict future events, with billions of images generated daily. The challenge is to convert visual chaos into actionable knowledge. The first major theme is the generative revolution, centered on diffusion models. These models create images by gradually refining random noise, much like a painter shaping a masterpiece stroke by stroke. LightDiff introduces rapid adaptation, enabling high-quality image generation from just a few samples, ideal for scenarios with limited data, such as medical imaging. FlowOpt offers intuitive, holistic control over image creation, streamlining the generation process. Sprint further accelerates diffusion, making these techniques practical for real-world deployment. A second theme is the convergence of vision and language, represented by multimodal models. These systems function like multilingual translators, recognizing and describing objects within context. GIFT employs gaze-shift-guided fusion to reduce hallucinations, while VLM Slide Eval grounds machine understanding in authentic data. Similar to United Nations translators who blend words, gestures, and visuals, these models integrate vision and language, resulting in deeper and more reliable AI reasoning. Explainability and trust form the third key theme. As AI systems enter medicine, law, and education, it becomes crucial for them to clarify not just their answers, but their reasoning. Saliency maps visually indicate what aspects the AI prioritizes during decision-making. The caption-driven explainability method by Collar and colleagues links predictions directly to human understandable concepts, while the On Thin Ice study explores how trust is managed in ambiguous scenarios. This transparency is comparable to a student demonstrating their problem-solving steps, rather than just providing the solution. Let's examine innovation in action with several research highlights. Caldera and team developed a scanner-agnostic harmonization framework for MRI scans, enhancing consistency across hospitals. Ronai and colleagues introduced FlowOpt, providing artists with rapid and intuitive control over image manipulation. Zhang Qi's group reduced vision language hallucinations by more than 20% with the GIFT model. Nain's team achieved over 92% accuracy in anomaly detection through human-centric preprocessing. Kaller's group advanced explainable AI by pinpointing the concepts underpinning model predictions. Today's featured paper is by Caldera and colleagues entitled Scanner Agnostic MRI Harmonization via SSIM-Guided Disentanglement. The problem being addressed is the variability of MRI scans across different hospitals and scanners, which poses significant challenges for research collaboration, diagnosis, and global medical studies. Caldera's team is motivated both scientifically and personally to achieve scanner-agnostic harmonization, aiming to make medical imaging more consistent and widely accessible to clinicians and researchers worldwide. The methodology introduced by Caldera and colleagues involves a framework that disentangles essential anatomical features from scanner-specific artifacts. Central to their approach is the Structural Similarity Index, or SSIM, a perceptual metric that evaluates image fidelity by analyzing structure, contrast, and luminance, rather than relying solely on pixel-wise comparison. Their method was validated on a diverse array of MRI datasets and imaging protocols, employing robust evaluation metrics such as the Wasserstein distance to assess alignment of intensity distributions and overall image quality. The impact of Caldera's work is significant. Their harmonization framework achieved a structural similarity index of 0.97, demonstrating remarkable consistency across scans. The error in brain age prediction was reduced from over 5 years to approximately 3 years. Additionally, the accuracy of Alzheimer's classification improved, with the area under the curve rising from 0.78 to 0.85. Most importantly, this framework enables global pooling of data, bridging gaps between laboratories, hospitals, and patient care, and setting a new standard for medical imaging research. Looking toward the future, AI and computer vision can be likened to an explorer setting sail into uncharted oceans. The next wave of progress will be defined by trustworthy, adaptable, and domain-aware models. The convergence of generative, multimodal, and explainable AI will amplify real-world impact, particularly in medicine, ecology, and the arts. As domain knowledge is integrated and new benchmarks are established, the horizon for computer vision continues to brighten, promising transformative advancements. In summary, computer vision is rapidly evolving along several dimensions: generative modeling, adaptability, and explainability. Efficiency and trust have emerged as the new hallmarks of progress. The work by Caldera and colleagues has set a new benchmark for medical imaging consistency and accessibility. The journey of discovery continues, and your curiosity helps shape the future of artificial intelligence. Readers are encouraged to explore these papers or participate in the ongoing conversation within the AI research community. A brief note on how this episode was created. The synthesis was performed using OpenAI's GPT 4.1 for summarization and narrative construction. Text-to-speech was provided by OpenAI, and images were generated using Google tools. All content underwent expert human review and refinement. While every effort was made to ensure accuracy, some oversights may exist. References are provided for each discussed paper, underscoring our commitment to transparent and insightful reporting. To stay ahead in the fast-moving world of artificial intelligence research, subscribe to AI Frontiers. Receive updates on the latest breakthroughs in AI, computer vision, and pattern recognition, and join a growing community of professionals and enthusiasts. Thank you for being part of the AI revolution. In this podcast, the latest breakthroughs in computer science and AI are brought to you straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so listeners can stay informed. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers provides daily updates. Thank you for listening. If you enjoyed this episode, subscribe for daily insights. More cutting-edge AI research will be featured tomorrow. Disclaimer: This video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.